I'll shut that down.
Are you using Firefox?
No, I was using Google Chrome. All right.
Maybe you should use Firefox.
So, what's your question now?
It was the admin situation.
Get into that later.
Okay.
So, if I change the problem just a little bit and I say, what's the probability of a king and then picking a queen, but now we do it without replacing anything. In other words, you pick the king out, you set it down. Then you either A, reshuffle the deck and pick another card, or you just randomly select another card. So here, it's still going to be the probability of the king first times the probability of the queen, dependent.
That's a Q on the outside of that K and Q, right?
This?
No, the
This?
first half. No,
Oh.
the first
First
that
one.
first thing, whatever it is.
Oh, that's P. Probability.
I'm telling you, right, so somebody can see. It's gonna be me, I put a key.
This is getting wordy, but in the back of your mind, you should be saying the queen is dependent on that first choice because you're affecting how many cards are in the deck and what's happening next. So, what's the probability of selecting that first king? 4 out of 52. When I get to the queen, it'll be 4 out of 51 because we stole one of the cards. Now that changes the probability just slightly. What's 4 divided by 52 times 4 divided by 51?
A number.
Well, yeah. 0 point, I'll give you that.
0.0060.
0060, which is just slightly different than 0059. So again, it's 0.6%. Of course, there wasn't much difference between 52 and 51. Now, as that denominator gets bigger and you just take one away from it, does it? What?
Oh, I was just playing. So now you got to be.
As the denominator gets bigger on these and I just take one away, do you think it's going to change the answer all that much?
No.
Nothing.
So, when in doubt, you can assume that you have with replacement where your fractions aren't changing from one number to another, especially when the percentages are really, really small, which means they have very, very large denominators. So far, so good? What about the probability of selecting a king and then another king? Do you think the probabilities would be different here? Without. With replacement, it would be the same. Well, yeah, it would be the same as picking a queen and the king with replacement. So without. So what's the probability of selecting a king first? 4 out of 52.
You dropped off.
Yeah. So what's the probability of selecting a king again after I already selected one and put it down?
3 out of 51.
3,
That's right.
because I took one of the kings away out of 51. This percent should be different because you're changing the top and the bottom. So what's 4 divided by 52 times 3 divided by 51?
0.0045.
0.0045. If you rounded it up, it would be 0.5%.
Didn't you take one away for the one before that?
If I'm selecting a king, it has nothing to do with selecting one of the queen cards. There's still 4 queen cards.
Okay.
But I lose one in the bottom because I took a card out. Here, if it's a king and a king, I took a king away, so it loses one of the kings, but I also took a card away, so it loses one of the cards. So it affects both the numerator and the denominator of the fraction. Right? That's just cards. What if I had something like this? Let's say that the probability of passing this class is an 80% chance. For each individual student, 80% chance.
Man.
It's possible. What would be the probability of a random 5 students passing? Doesn't matter. Random 5. I go into the classroom and I grab 5 people and I say, what's the probability that each one of them passed? Well, then it becomes a selection. What's the probability the first one passed?
I believe
80%. What's the probability the second one passed?
80%.
80%. Third one.
80.
Fourth.
80.
They're all 80, right? Because they have no effect on each other's grades. So, just like with the king and the king, we have, well, not this one. Just like the king and the queen, we're going to assume it's without, or with replacement. The first one has an 80% chance of passing. His passing has nothing to do with anybody else. So when I do this, it's going to be 80% times, that's the first student. Second student, 80%. Third student,
80%,
80%. Fourth student,
80%,
fifth student.
80%.
Is there an easier way to write that?
80
80 times 5.
No, not times 5.
to the fifth.
To the fifth. So this would be 0.8 on your calculator, caret 5. So what is 0.8 caret 5?
I don't have one.
0.8 what? On the calculator?
0.8 caret. It's right kitty corner to the 7. Raised to the power of 5.
3.2.
How you do that?
Caret, it's right next to 7.
0.3276.
Yeah,
0.3268,
32768.
blah, blah, blah. Oops. 8. Getting a little too low. As a percent to the nearest tenth, what would that be? 32.8%. So even though the percentage for each one of them passing is 80%, to get randomly 5 of them that actually pass together is lousy 1/3 of the time. So 1 out of 3 chance of actually finding 5 that all passed. A third of the chance. 33% is a little 1/3. 1/3 chance. Change the colors. Get bored of green. Black.
Red.
Now let's get into something else. Well, same idea. So if the probability of passing is equal to 80%, what's the probability of failing?
20%.
20%. Why?
Because 80 from 100% is 20.
He was 100.
In a class, you either pass or you have no other options. So this has a sub-idea that this bottom one is called its complement. It's called its complement. It is the complete opposite. Now be careful with complete opposite. It doesn't necessarily mean you just shove the word not in there, because that sometimes does not work. So for complete opposites, the formula becomes this. The probability of an event is equal to 1 minus the probability of the events, and I put this dash up here, and that dash represents, take a guess, the word
Not. Compliment.
complement. Not is not complement, not is negation. Complement is a little bit more complex. In this case, it works pretty well. If you're not passing, you're failing. There. So when we had,
Is that a 1?
this is a 1. Do you want me to write it fancy?
Yeah.
Fancy 1. No one ever writes 1s that way.
I do.
Do you?
Yep.
I never write 1s that way. So, if the event I'm interested in is failing, then the probability of failing is equal to 1 minus the probability of passing. Now, it could be 1 if you're in decimals. What's the other number it could be if it was a percent? 100. So 1 minus the probability of an event, this is in decimal form. If you want to talk about percent form, you have to do 100 minus the complement. 100. This would be percent. So this is also 100 minus, what's the probability of passing? 80%. Which comes up to be your 20%. That's where it's coming from.
Okay, what's that little thing you did?
The little thingy here,
Yeah. Okay, never mind.
complement. So when you write this, E with a little dash on it, this is the event's complement. The event's complement, a little dash. Now what's nice about this formula is if the event is really hard to find the probability of, sometimes it's easier to find the probability of the complement and then go backwards to get to your event. I'll have one of those in a little bit after we do some more of these types of problems. All right, so if the probability of failing is 20%, what is probability of 5 failing? In other words, I'm going to go into a classroom, I'm going to randomly select 5 students, and I want to see if they're all failing. So how would I find it? It would equal 0.2 raised to the 5th power, caret 5. So what's 0.2 raised to the 5th?
Oh, wait.
0.00, I'll give you that one.
32. Yeah. Oh, 0, 32.
32?
0, 32.
Another 0 to 32?
Yeah.
Much smaller than the other answer. The other one was what, about a third, right? 33%? All 5 of them passing. This is 0.032% of the time. In that case, I'd go a little bit further than nearest tenths, because if I just go to the nearest tenths, the percent is 0. And I don't want to talk about just 0%, because there's a little bit of a chance, just not much of it. So, my next question is the hard one. Put a little star by it. What is the probability of finding at least 1 out of 5 students failing?
Where do you get the F? The spelling. It's supposed to be the spelling. Right there.
Where are you? Oh, this F? Yeah, 5 failing.
Okay, so
Okay.
how you get 2 to the 5th power?
Well, the probability of failing is 20%. So it's 20% for the first student, 20% for the second, third, fourth, and
Okay.
fifth,
okay,
and you just multiply them all together. Don't add them because you'll eventually end up with a probability bigger than 1. You can't do that. So here's the tricky one.
Okay, so how did you get that 0.032%?
This one,
Uh-huh.
0.2 to the raised to the 5th power. On your calculator, 0.2 caret 5. What does it mean to be at least one of them is failing?
1 or
1 to 1.
1 or more. So if I had to separate this probability, I'd have to say, well, what's the probability of 1 of them failing, and then 2 of them failing, and then 3 of them failing, and then 4, 5. So that would separate into 5 separate problems, which gets kind of messy. So what is the opposite, the complement of this? What is complement? What is the exact opposite? Not negation. What is the exact opposite of at least one failing?
All of them.
All of them passing.
I would say 1.
So the complement of at least one of them is failing would be all are passing. If all of them are passing, not one of them has failed. And that's the goal of this whole part. So what I'm going to look for first is what is the probability that all of them are passing? Well, we did that earlier. So what's the probability that 5 of them are passing? It was what, 33.8%?
32.8%. 32.8.
32.8%. So we already have that answer. The probability of every single one of them passing is that. So what's the probability of at least one of them failing? Well, these two ideas passing and at least one are complements of each other. So the probability of at least one F is going to equal 100 minus the probability of all 5 of them passing. This is where that complement comes in handy. So instead of finding out 5 answers and then putting them together, you take the opposite answer and take it away from 100. So what's this one equal to?
One field.
This would be 100 minus
32.8.
32.8, which is equal to
67.2. 67.
67.2%. So the probability of randomly selecting 5 students and having at least one of them failing is higher than all of them passing, which is kind of cool if you think about it.
Where'd you get the 32.8?
From earlier,
Oh, I see it now.
the 0.8 to the 5th.
Uh-huh.
Oh, this black marker is horrible. Stick with blue.
So,
Go ahead.
you're saying if 80% of the students that take the class pass,
Each individual one.
it's easier to find one failing than it is.
At least one failing. Now, wait until the next part of the question. It's actually even better finding the other direction. For example, I know. Wait a minute. There's one more. What is the probability of finding
Start with that.
one out? No, I should phrase that better. Finding at least one student out of 5 that passes. Wow, what the heck happened there? So where's the complex part of this question? That at least part. So we have to take care of at least one student that is passing. What's the complete opposite of at least one student passing?
All of
All
them.
All of them failing. So my complement here is going to be all failed. Okay. We found that probability earlier. What was it? Probability all fail is equal to
67.2%.
0 point. No, it was not.
67.2. Oh, not that number.
All failing.
Oh, that's past.
Was it point
Zero,
0.032% of the time, you will find every single one of the students has failed the class. So what's the probability of at least one pass? Well, that's the complement of the one above it. So how do I find the complement? You do 100 minus 0.032. Since these are both in percents, I'll just write it like that. What's 100 minus 0.032?
99.96.
96.8% of the time. So when you say, oh no, the percentage of finding at least one that has failed is higher than all of them passing, if you take a look at this, the probability of finding at least one passing is huge compared to at least one failing. So that 80% still pulls its weight in a weird way. So that's how you deal with at least complement.
That's gonna be a fail.
Well, it's several of the questions on it. I think that it's a tire popping Moodle.
Yes, the
Tire
tire
popping. Tire.
question.
A tire question. Ah. Next topic. It's a small topic, but we're going to expand upon it the rest of the class, so Get used to it. Conditional probability. Let's go back to our little table. Male, female, and women, whatever.
Can you like not do two charts because, I mean, up here, do two columns because when I get on Moodle and it's three, it just confuses me.
Fine, here's 3. High school, 2-year, 4-year. Really doesn't matter one way or the other, but 7, 13, 21, 14, 19, 30. Just making up numbers. And the question I want to ask is, what is the probability of selecting a 2-year degree? We'll start off easy, warm ourselves up. Before I answer this question, what should I do? Sum them all up, get all your totals. Over here, this would be 21, 20, 32, 51. Going this way.
41.
This is 20, 41.
41,
It's 20, 33,
63.
63. And make sure that the bottom 3 numbers and the side 2 numbers add up to exactly what they should be, which is 104. Does this add up to 104, the bottom 3?
Yes.
They should. If they don't, you just add it wrong.
Yeah.
Okay. So in this room, there's 104 people, separated as male and female, women and men. And if they have a high school degree as their highest degree, 2-year degree as their highest degree, or 4-year degree as their highest degree. All right. So what is the probability of selecting randomly someone that has a 2-year degree? What would you look at?
The 32.
Yeah, 32 and 104.
You'd look at your 2-year degree, which is the 32, right?
Yeah,
And then out of the entire room, because they didn't really have any other sub-classifications, 104. So this probability of selecting someone with a 2-year degree would be 32 out of 104. Fractions are nice in this case. What's it reduced to?
30.8.
No, reduce. Fraction, reduce. What goes into both of them?
4 over 13.
4 over?
13.
Really?
Yeah.
Oh, that's kind of cool. Kind of like cards. 4 out of 13. So the probability of selecting a 2-year at random is 4 out of 13. If you want to change it to a percent, what's the percent?
30.8%.
30,
0.8.
30.8%. Is that right?
Yeah, 38.
Okay. So that's the easy question. Let's make it a little bit harder. What is the probability that a 2-year degree holder is a woman? This is what's called a conditional probability. You're making the entire room smaller by focusing on one group, and then out of that group you're looking for another subgroup. So basically you're taking the room and cutting it into 2 subgroups. One's a little bit bigger than the other. So it's always important to know which one's the major subgroup and which one's the minor subgroup. So which one's the major subgroup?
2-year.
2-year. So this is the major. And the women is the
Minor.
minor. And it's always minor over major. So the probability, and how to write this gets a little complex, so it's best just to say,
2 years later.
you're looking for a woman out of the 2-year degrees, is the proper way of writing it.
I did.
But if you want to just put it in English, that's fine. If you just want to write the sentence and say it's equal to something, that's fine. What's what? Major? Ooh. What? Someone said said so.
I'm gonna have to remember that that's a woman, cause I'm gonna think it's with 2 years.
So, when I say what's the probability of a woman, given that they're a 2-year student or 2-year degree holder already, the first number is going to be 19, because those are the women in the 2-year degree column, so it'll be 19.
Sorry.
Brush your hair. Over. The major group is 32. So because we cut it into a smaller portion, in other words, we took the 2-year degree people, we put them in one room, and out of that room we randomly selected somebody and we wanted to see if it was a woman. What is this as a percent? Because it doesn't reduce.
59.4.
59.4.
So Mr. K, we can't reduce it, turn it into a decimal.
Well, it depends on how the question is phrased. If it wants this out of that,
Oh,
4 out of 13, 19 out of 32, those numbers have to be reduced. If it just says, give me a percent, it'll say number in a unit, then you give it a percent. Round it to the nearest tenth. Round it. What is probability of selecting a 4-year from the men? Now, who did I shove in one room? The 4-year degree holders or men?
man.
Which one?
Man.
Men. Well, yeah, I wasn't sure what you said. Mean. So we're shoving all the men in one room, and out of that room we're seeing what's the probability of selecting a 4-year degree. So who's the major group?
4 year.
4 years.
4 year.
Man.
Men. You just said that. When you shove all the men in one room, they're the major group. Notice the order of them has changed. So you have to be really careful which one is which. So therefore the 4-year is the minor group.
What?
What?
Oh, never mind.
Okay. What? So in symbol form, which is kind of ugly, what's the probability of selecting, what am I selecting? A 4-year from the men. So the top number is going to become
13?
51.
Is it 51?
No.
No, because
It's
51 includes
Um,
women, and I just took all the men and shoved them in one room.
I mean,
Yeah.
So your focus should be,
41 is 20.
41.
Oh,
Yeah, 21.
so 41's the top?
No, 21
21.
the top and 41 the bottom.
21 is the men that have 4-year degrees, 41 is how many of them are men. So the major number that goes in the bottom is 41. That's how many men we're dealing with. What goes in the top is, out of those men, how many of them have 4-year degrees? 21. That doesn't reduce also, so we're kind of stuck going to, what's a percent?
51.2.
I was going to say it's really close to 50. 51.2% of the time, you will select a 4-year degree from all of the men that are in this room. So that's how this breaks down as a conditional probability. It's not break time. Oh, it's only 10:08.
God bless you.
So this leads into drug disease testing.
What is that word?
Is that disease?
Have you ever been? Yeah, did I spell it wrong? How do you spell it?
D-I.
D-I.
S-E-A.
So, has any of you ever done a TB test?
Yes.
Those are fun, right? They stick you and they say, come back if it comes up as a reaction. If it comes up a reaction, like,
Something wrong.
I'm not telling anyone, but of course then you get a lot of people sick. Drug testing, of course, is very prevalent. And there's a lot of schools that want to drug test their kids, which I think is kind of silly.
Test staff.
Drug test is staff,
You
yeah.
got that right.
Wonder if I passed. Oh well. So, how does a drug test work? Well, it breaks everybody into 4 groups automatically. If you give a drug test or a disease test to a group of people, it automatically breaks them into 4 groups. They are going to either test positive or test negative. In other words, the test is saying they have the disease or they don't. They use drugs or they don't. The other groups are what?
Female?
Nope, male and female is irrelevant.
Non-user.
Non-users and users. Sick people or healthy.
Yeah.
So I'm going to put sick here and healthy here. If you do it to a random group of people, they're either sick or they're healthy, they're drug users or they're not, and the test is either going to test them positive or negative. So that's the breakdown of every test that you can give anybody. Now, if they are in the sick column and they test positive, we call this a true positive. In other words, the drug test or the disease test actually worked. It actually worked on the group it's supposed to work
That's
on.
how you spell positive.
The 2 S's or 1? It's probably just 1 S. I love my double letters. All right.
You said you got not from math, not English.
Exactly. I never worried about spelling.
Strong point.
It is not one of my strong points. You remember spelling bees? We used to stand in a line, and if you got the word right, you got to sit down. I was always standing in line.
You never said that.
I never sat down. All right. If the drug test is given to a healthy group, what would you expect?
Negative.
It would be a negative. So this is what's called a true negative.
Okay, say that one more time, please.
I'll say it one more time. If you are a healthy person, how would you expect to be tested?
Always.
Oh, negative.
You would expect to have a negative test because you don't have the disease.
Right.
So if you are a sick person and you test positive, we're going to call those true positives. If you're a healthy person and test negative, we're going to call those true negatives. The dangerous part of any test is this one right here. You're a healthy person, but you tested positive. So this becomes a false
Negative.
positive. All right. Therefore, if you're sick and you test negative, which is also very dangerous, because then you go around, Ebola, remember that? And if they tested someone negative and they are still really sick, and that becomes this group right here. So this would be
Talking
false.
about Ebola, they tell me that an employee of Virginia train that came through there and they had they thought somebody had Ebola and everybody got off the train had. So
What disease would you be more nervous about? Measles or Ebola?
measles,
Measles. Why?
because it's more prevalent.
Because if you're in a room with one person that has measles, you have a 90% chance of getting it. I think I'll be not worried about Ebola so much. So this would be false negative. So the table always breaks down into true positives, true negatives, false positives, and false negatives. Do you have to know where they are? Yes, because most of the conditional probabilities are based on this table.
How many problems we all write down?
Next week, not this week. I'm just getting a little ahead of myself. So we're going to talk about what's called specificity. No, not specificity. Sensitivity. Oh, I know how to spell that one scarily. Sensitivity.
I watched a video.
If you go to Walgreens and you look at a box that says drug testing, it says 99% accurate. And what they're talking about is its sensitivity. Sensitivity literally is true positives over, I have to be really careful.
All of them have that disease.
All of them that have the disease, but how do I want to say that?
All who got it.
All sick, I guess. All druggies, whatever.
All sick, okay.
So sensitivity is the true positives out of all the ones that are sick. Then there's specificity. Specificity.
Just the opposite.
Well, it's not the opposite.
Okay.
It's the true negatives out of all the ones that are
Not.
healthy. Here. So true positives out of all the sick people, true negatives out of all the healthy people. All right, so let's have an example. For example, if I have this table, let's say it's a drug test, uses, does not, positive test, negative test. Throw some numbers in there. 17, 3, 44, 201. So what is the 44 talking about?
False positive.
Which would be the people that do not use drugs but still tested
Positive.
positive for use of drugs. What's the 3 represent?
They
They use the drugs, but they tested negative. All right. So when I look for sensitivity, it is a conditional probability. What am I interested in? What's my main group?
All
True
of
positive. So true.
Not true positives. What is the main group of sensitivity? All the users in this case.
20.
So there's 20 users. So the main group is
20.
20. All sick. The top number is the subgroup out of that I'm interested in, which is
17.
the 17 positives. So this has a sensitivity of 17 out of 20. In other words, they would advertise it as, we'll catch 17 out of 20 people that actually use drugs. And it sounds really good. What's that as a percent?
85.
Well, maybe not so good. So about 85% of the time, this test will catch drug users. So they advertise it that way. It's not the best thing, but that's what they do. What about specificity? Now specificity leans on the other direction. What about the healthy people? How does it handle them? Well, what's the main group here?
44.
Or not healthy, does not use.
245.
245. It's the total of the does not use. So you get 245 in the bottom. What's the number on the top?
201.
A lot of people will go for that 44. Be careful. You're curious about the true negatives, which is 201. The 44 are the false positives. So what's 201 out of 245?
82%.
82%. So this test will accurately show that you don't use drugs only 82% of the time. That doesn't sound very good. It's not a very good drug test. Oh well, I just made up the numbers anyways.
So, 85% of the time it'll tell you that you do use drugs, and 82% of the time it'll tell you that you don't.
Gotta be careful. It's not that you use drugs or don't use drugs. It's how accurate it is to catch the people that actually use drugs 85% of the time. If you're going to use drugs, it'll catch you 85% of the time out of this group. If you don't use drugs, it'll correctly show that you do not use drugs 82% of the time, which is not good. Because that means the other percent of the time you are, you're in that other number there, 44. Your employees are going to look at you really closely. So what you're talking about is the reverse of this, which is the other half of what we're going to talk about. What happens, let me come up with another one. Sick, healthy. And positive tests and negative tests. In the United States, is TV very prevalent?
I think so.
No.
Used to be.
It's about 1 out of every 100,000. One person out of every 100,000 has TB. If you go to the Philippines, do you think it's more prevalent?
Yes.
Yes. It's about, what did I write down?
I seen something on the internet about that.
I found these out. It's in the United States, it's 1.2 per 100,000 U.S. born. U.S. born. It's 15.6 per 100,000 for foreign born. So every time they ask you if you've been in contact with TB, one of the things they ask you is, have you traveled to other countries? And they know which countries that it's really prevalent in. Kind of like Ebola, if you're in East Africa or West Africa, you're in kind of trouble. So in the U.S., TB tests might look like this over here, where there's very few people that actually use. But if you go to the Philippines, the numbers are a little crazier. So they would have something that would look like this. No, that's too big.
Get right.
Their numbers for sick balance with those that are healthy. Since it's more prevalent there are more people that are sick. So if we still do sensitivity and specificity, what's the sensitivity in this case? What do I look for?
410.24.
So I have to add these two together, and it's what, 424? So it would be 401 out of 424. What's that equal to?
94.6%.
94.6%. So the test for this tuberculosis over there, and there's several different tests that they could do. The easiest one is that one little prick, but there's other ones where they actually inject you with a partial dead virus or something like that. So this test will catch 94.6% of the people that actually have tuberculosis in the Philippines. What about the specificity?
708 over 8.
708 over the total group of healthy people, which is 817. 817. So this would be 817. How's the specificity percent?
86.7.
Not too bad. Your goal, of course, is to find the sick people. When you're in a sick, healthy condition, it's more important to find the sick people than it is to find the healthy people, because you really want to get those sick people quarantined. So those are great numbers, except for one problem. If we go back to this one, and let's assume this is the US TB test, whatever. What if we go the other direction? Instead of going up and down with our main group, what if we go left to right? In other words, if I looked at these two numbers and looked at these two numbers as the main groups, and the subgroups being true positive and true negative, we get what's called a PPV, which is a positive predictive value. When I look side to side, what's the main group? The positives. How many are there?
17.
No, all of them.
61.
61. So that becomes my bottom. What's the top become?
60 over
17, because I'm interested in the true positives. So this works out as true positives over all positives. What's that as a percent?
27.9.
27.9%. Did you say it was break time? Yeah, we'll finish this later. Break.
What, already?
Yeah. So this is the PPV. It is all the positives over all the people that tested positive. All the true positives over all those.
She late.
Always. She was late the first time around too. The other one is called NPV, negative predictive value. So when we're doing NPV, we look at all the people that tested negative, and we compare them to all the ones that tested true negative. So it's true negative over all negative.
That's PPV. PPV?
True negative.
Okay.
True positive over all positive is PPV.
Okay.
True negative over all negative is NPV. Negative predictive value. So, how many people are we talking about here total? All negative. 204.
204.
So that would go in the bottom.
Mhm.
And the number on the top would be?
3.
No.
201.
True negatives. 201.
I'm
He did
serious.
it so confident.
So this
Yeah, I'm
thing.
serious.
He is.
98.5.
98.5%.
Oh, be quiet.
What does it mean? So if we're looking at NPV, we're looking at just the people that tested negative for the test, and we want to know what percentage of them actually were negative, actually did not have the disease, actually did not take drugs. This is pretty good NPV, having it over 90% like that. Let's do it over here for this one, where it's more prevalent to have a sick person or a drug user in the numbers. So for this one over here, what is the positive predictive value?
401 over 424.
401 divided by?
424.
Nope.
No?
5.
Your main group is this.
Yes.
5.
10.
10.
510. There are 510 people that tested positive for this tuberculosis. So that'd be over 510. So what's the PPV here?
78.6.
78.6% of the time. What about the NPV? What am I looking at here for the main group?
708 over 817.
What's the main group though?
87.
Not number.
8.
Oh, I ain't adding.
What's the main group?
731.
Not a number.
All the
All the negatives,
731.
which is 731 people. So that goes in the bottom. Now out of those 731,
708.
who am I interested in?
708.
The 708, the people that tested negative when they really should, true negatives. So what's 708 divided by 731?
96.9.
96.9% of the time. So that's saying if you tested negative for the test, more than likely you do not have the disease. If you tested positive for the tuberculosis, there is a chance that you still do not have the disease. That's not a very high percent. So, as the numbers are closer, I mean compare, PPV over here was 78%, PPV over there where it wasn't very prevalent is 27.9%. If this was a drug test and your kid tested positive, which one would you be able to argue more with? The more prevalent or the less prevalent? What do you think high school prevalency of drugs is?
A lot.
You think it's a lot?
Yeah.
Really up there, like 100%?
No,
No, it's
probably 50%.
You think about 60?
I think it's 40.
Not just alcohol, I'm talking drugs.
I think it's 50%.
It's amazing what people's perception is compared to what really
It
is.
So ask that
Okay,
question
can I
again.
ask
If it was up in the 60%, this test, you wouldn't have very much argument. If it was a very low drug usage in a school, then this test you'd have a large argument saying, I don't think my kid does drugs. Look at what you have here. So it depends on if a lot of them use it or don't. If a lot of them use it, that PPV is going to be high one way or the other. If a lot of them don't use it, it's going to be rather low.
Okay, so what's 23? All the people that's,
This is 23? These are people that are sick or use drugs that tested negative. So they're called the false negatives.
Yes.
Yeah, false negatives. False negatives.
So, I think it's what, when you're 3 years old or something, they do a TB test? My brother actually tested positive for TB.
3 years old?
They test you? Something like that.
I got myself tested last.
I forgot where they tested me.
tested.
I know they tested me when my wife got sick because she got a lung disease and they weren't sure what it was, so they tested everybody for TB in our family. That was fun.
I got tested last year.
He got tested, he tested positive. They told us to
Tested
get
when you
Every time I'm
But in the United States, because it's low prevalence, the PPV would be really low. So just because you tested positive means nothing, but they'll be cautious.
I mean, I had some.
But then they do another test right on top of it. Once you test positive, they do the next one, which is much more accurate, but not, it's more expensive too. They don't want to go to the expensive one if they don't have it. I guarantee it's negative for that. Otherwise, he would be confined to where
Oh, no, I mean,
he was.
Yeah.
they told him if he ever took the test again,
Yeah.
that he would pop positive, but he's not.
He must have something in his system that just tests positive for it. That's it.
I do. I have to go get an X-ray.
You
can't
do?
that. Yeah. I
Good
have to get an
Lord.
X-ray to prove that I don't have it.
See?
My cousin tested positive and he had to be put on some strong
Right
antibiotics.
at top light, bigger.
Plus he's got HIV. So he was more susceptible to get it.
The hard part. Sensitivity, specificity, NPV, PPV, those are all easy because the numbers are in the table and you just have to do some, calculations. The other way, people don't like. For instance, nah, I'm just making up numbers. A local high school used a study that stated that 30% of students smoke.
What they smoke?
That smoke to determine
Rocks. Cigs. Cigs, right?
how
Bong.
a smoking test with a sensitivity of 90% and specificity of 85% would work. Just making it up. So there's all these studies out there. You can always look up one.
So we
Doing
have
a
to make
random
our own
study
box.
across high school students, how many of them smoke, how many of them drink, how many of them blah, 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 blah. Break it all down.
So we have to make our own box and plug those numbers in.
Right, we have to figure out.
Okay.
Now, there's only one number missing. What is it?
The total amount of high school
The
students.
total number of high school students. So, the high school has 1,250 students. So what you want to calculate out is the PPV and the NPV, but you can't do that given what's already there. So you have to create something that leads into that information. So we need to make the table. The problem with the table is we only know the total number of students and a few of the percentages, the sensitivity and the specificity. But from those, we should be able to find all the numbers that go in this table. So here would be smoke, doesn't, and testing positive for it, testing negative for it. Bless you.
God bless you.
Bless you.
Bless you.
Sorry.
Time for the flu test. So, what does this mean, sensitivity? What does it mean that it's 90%? True positives out of all positives. So, if the sensitivity is 90%, and that's equal to the true positives over all positives, or all, it's not all positives,
So,
All who have the, all who
all that
smokes.
smoke in this case, all that smoke. So what I have to find out is, how many of them smoke? So how do I find out how many of them smoke? What numbers would I plug in? There's only a few available to me.
Okay,
Well,
30
the one
going
solid
on
number is
The total.
The 1,250 students.
Right.
What number goes with the 1,250 students
30%.
automatically?
30%.
30%. So 30% of these students smoke. So can I find out how many students smoke?
Yes,
Yeah, how would I find it?
multiply.
So I take my 12,500 students and multiply by
30%.
30%.
Wait.
375.
375.
So out of the 1,250 students, 375 students smoke. Now these don't always come out to be whole numbers. So here's the thing. If it was 375.2 students, do you write 375.2?
No, you
Cause
round
cause
down.
cause no person-
Unless you're willing to cut someone into parts, you have to round it to the nearest whole. Now that leaves a possibility. I had one problem where everybody smoked and nobody tested negative for it. So I had a 0 here, but I was forced to put a 1. So if you ever get 0, you're forced to put a 1. You can't have 0. It's eventually going to give you some problems. All right. So where would that 375 go in my table?
True positive.
Oh, no.
True.
Would it go in the true positives?
Oh, no,
Because
when
they
I smoke.
Under the people that smoke. It is the total number of people that smoke. So you go to the very bottom, and this is 375.
Whoa.
So this becomes 90%, but I'm not going to write it as a percent anymore.
Okay.
What?
How did you get the,
375.
375?
the other one?
The 1250?
Yeah, like, what you put in grades, like,
30% of students.
There's 1250 total students in the school, and out of them 30% smoke.
okay.
So I just did 30% of the number of students. And that becomes the total number of smokers. Now, with this little formula, there's other ways of doing it, but I'm going to do it with the formula. So change the 90% into a decimal, because technically the other side is a fraction, which would just change into a decimal anyways. Do I know the true positives? No, let's call that X. Do I know all of them that smoke? Yeah, that's 375. How do you solve for X?
You multiply.
So the long way, but makes more sense, it's going to be 90% of those that smoke. So that sensitivity tells you how to find out the ones that actually tested positive that also smoke. So what's 90% of 375 to the nearest whole student?
337.
338.
338 or 337?
337. Are you gonna round down? It's 30 at 0.5.
Round. 8. 338. It shouldn't throw you off if you go the other direction, but I round up. So this would be 300.
You said round down on the video.
Did I?
That's why I said that.
That's probably why. Oh, I did, didn't I?
Yes.
Yeah, round down. 337. There's a reason for rounding down.
So if we got that wrong, then give us a credit.
It said round up.
Since you
and it don't matter.
The video, I think I said round down, so it matters.
I apologize.
Yeah, round down, because what that does is it leaves something for here. It leaves something for there. So how do I find that missing box in between those two numbers? Just subtract. So what's left over for the negative testers?
38,
There's 375 that do smoke,
38,
337 do smoke.
So you
Tested
subtract
38.
38. Okay.
Unless you gotta round down.
Now, how do I find out the ones that don't smoke?
I'm always right.
I don't know, you do this.
Okay, 375 subtract 1250, right?
That's a good start. So this will be 1250. Take away the 375 that do smoke. Complement kind of idea. You take the opposite part of it.
Alright.
How many are left over?
875.
875.
875.
875. I love people that just yell out numbers that are wrong.
So repeat that, what you said?
Huh?
Repeat what you just said.
Nothing.
Okay.
You knew I was going with that.
Yeah.
But continue.
All right. So, what's the formula I set up for the dozen? 85% because that would be the specificity.
Okay, that's 85.
So it would be 0.85 is equal to
X over 875.
the true negatives divided by 875. Specificity is true negatives over
All this, they don't.
That smoke.
true negatives over all the ones that don't smoke. It's hard to phrase it that way, but man, that's how you do it. So how do I solve for the true negatives?
337 divided by 875. Is that right?
Huh?
875 times.
Multiply both sides by 875. So your true
Okay.
negatives are going to equal 0.85 times
875.
875, better known as
Oh, 740.
743.75.
743. Yeah, 743. So this would be 743 are true negatives.
That's a long problem with that, ain't it?
What's that leave for the
You should
false?
again.
Subtract again.
743.
How many?
I don't know.
132.
I'm not gonna say.
100 and
32.
oh, 32. 32. 132.
That's a lot of work.
Yeah. Well, I wouldn't say it's a lot of work. I say it's a lot of typing things on your calculator.
There's no way to kiss this like grandma.
Grandma's easier than this.
Okay, so what did you say?
Grandma's much easier. So, out of this information, what's the PPV?
What would that mean?
I didn't think that.
It would be-
Sensitivity and specificity are great, but it's irrelevant unless you know the PPV and the NPV. So what's the PPV?
330. No, it would be 337.
What's the main group?
130.
No, not numbers. What's the main group?
Total positive.
Total positive. So you're looking at these two numbers. What's the total of the positives?
769.
Huh?
469.
469.
7.
I couldn't read my own handwriting.
469. So that would be the main part of it. What's the sub part of that group?
337.
The people that actually tested positive, that were actually positive.
337.
True positives, 337. What's that come out to be as a percent? If anything, you've learned how to write a decimal as a percent.
What'd you say?
What's 337 divided by 469 as a percent?
You want the
71.
decimal?
71.85.
71.8%. That's pretty
It
high
would actually
PPV.
be 71.9% because it rounds.
Why did you
It's
round down?
71.9%.
Man,
The
so
question
when do we
is-
okay, so why do we round down on one and then round
Oh,
up on the other? Like,
You round
why
down,
is it-
but if you round up, you might leave nobody for down here.
Okay,
So you round down, so it always leaves
at least one.
at least
but-
one for the other one.
Thank you.
You're welcome. Why do I round up here? Because it's a regular old number.
Okay, that explains it.
All right.
Thank you.
NPV, what's the main group?
All that don't.
Oh, the tested negative.
All
All
the
the
tested
tested
negative. So I'm looking at this group. How many are there?
781.
781. So that would be the main group here. All the people that tested negative, 781. What goes up top is the true
Negative.
negatives, which is 743. This is like 90-some%. Well, no, it's not.
95.
Is it?
95%.
Even?
95.1%.
95.1% of the time. So this test is actually pretty good. It has high percentages for everything. Now, if it had a low percentage for PPV, and the school said, hey, your kid smokes, I would say, well, this percentage over here for the PPV is low, so therefore there's a possibility that your test actually tested wrong. Because this would be those that tested positive that actually do smoke in this case.
Okay.